Look at that. So smart. Okay. Can y'all see that it's recording? No? Okay, this better last the whole time or I'm going to be mad. All right, 8.2 functions. Okay, first off, we're going to do Xavier earbuds out. Guys, I don't want to see those in your ear. They're going to be in my pocket for the rest of the day. Okay. Don't worry, I'll get them back to you at the end of the day. Okay. First thing we're going to talk about, well, before we talk about functions, which deal with a lot of inputs and outputs, we probably should define those words. So we're going to do a little T-chart. Okay? We're going to do a little T-chart here. I don't know. There might be like 5 or 6 things here. And make yourself a little T-chart. Sorry, I'm on your table. Stay on task, Anthony. I don't know, you're looking suspicious back there. Okay, so let's talk about the things that we already know for input and output. I'm going to use 2 different colors here. Okay. All right. So if I say X, what's its opposite? Or the corresponding Y? Oh my gosh, y'all are getting it. X and then Y. If I say input, you say all right. If I say domain, you say range. Now we're getting into some new stuff, okay? Range. Okay. No, it does. Okay, the only one that did was input and output. Okay. Domain. So all of these things we're putting on the left side in green, those are X values, input, domain. So if I ask you what's the domain of the relation, you're going to list me out the X values. Okay. If I said what's the range of the relation, you're going to list me out the Y values. Then let's talk about, this goes with science class. X is the independent variable. And what is the Y? Dependent. Right? The Y value depends on the X value. So the X value is the independent variable, the given, the first thing. And then the output is the Y value, or the dependent variable, or the range. I had more lines, but I honestly think that that's probably all we need for pre-algebra. We don't need to get into super fancy stuff. We can add this. So if I'm plotting a point with an X and a Y, the X is I start at the origin and I go which way? Left and right. Okay? So left and right. And then the Y's go up and down. Thank you, Leah. All right, that's one page of functions. All right. Now I'm going to give you the second page. So flip over to your next page. This is the page. Yeah. We're going to write stuff. Just flip it over to the second page. We're going to write a little bit of stuff. All right, everyone got that? This just gives my third block plenty of time to get it glued in and prepared for. Okay. I'm gonna put a little dot, 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 still doing functions. Okay, so we are gonna talk about how to recognize a function from those these four diagrams, okay? We're gonna recognize a function from ordered pairs, table, graph, and mapping diagram. But first, we're gonna start off with the table, okay? So there are four relations here, okay? There are four relations, four tables. One of these tables is a function or represents a function, okay? So you got four relations here, four groups, four tables, four groups of points, and only one of them is a relation. Looking at the numbers, don't worry that some are horizontal tables, some are vertical tables. Some say X, some say Y, some say input, some say output. I want you to focus on the numbers. I'm going to give you 1 minute. Tell me, let's do this. 1, 2, 3, 4. In 1 minute, see if you can figure out which one of these is the function. What looks different? Okay? What looks different? Find the one that looks different. Which one? Only one of the four is a function. There's a lot of numbers here, so I'm going to break it down even further. I want you to look at the x values. Functions, you kind of focus on the x values. So which one of these, looking at the x value, you might find something that's different, but it may not be the difference for a function. Y'all think you have one? Someone got it.
Who got it? What's the name?
And the explanation is even good.
It's whatever the answer.
Leia, which of these is a function and why?
It's 4 because the x value doesn't.
The x values do not repeat. It's that easy.
Oh, I just noticed that.
Okay?
Good job there.
Okay. So down here at the bottom, if it's a function, the x values do not repeat. That means you don't see the same x value twice. Okay. So all you have to look at are the x values. Here, the input we've talked about, that means x values. And then here's these x values. Okay. This one is the function. Number 4 is the function. Okay, I need like a different color highlighter so I can have skin color. All right, So this one here is the function, number 4. Okay, those x values don't repeat. What number repeats on number 1 that makes it not a function?
3.
The 3. Okay, those 3 repeats. In your notes, you should be writing this down. Number 2, this relation. What number repeats in the input? 2, right? So that 2, that repeats. The x value repeats. And then on number 3, we got 2 7s down here, that repeats. Okay? Now, if you'll notice in the y value, so we know number 4 is the function. Do you see the same y value repeated? You see the 9s? That's okay. You can have repeating y values, you just can't have repeating x values. Okay? So the y values do not repeat. I'm sorry, the x values do not repeat. The y values can repeat. Okay, the y values can't repeat. Isn't that so easy now? If I gave you another list of tables, you could be like, boom, that's the function. Okay, there is a very fancy definition that you might see, which says each input, or x value, each input has its own output, or the y value, okay? Meaning that each x value has its own single y value, okay? Like that in the example here, number 1. Each input has its own output. Well, 3 has an output of 0, but it also has an output of 2 and an output of 4, okay? That's not its own, it's sharing its output, okay? It has multiple outputs, it can only have its own, okay? Its own output. Okay, so that's why number 1 is not a function. Same thing with number 3. The input of 7 has an output of 12 and an output of 16. It has to have its own. It can't have 2. Okay, it can only have its own single one. Okay, it's not going to share outputs. All right, so this is the fancy definition. Each input has its own output, but you could just think the x values don't repeat. Okay, the x values don't repeat. If they do, it's not a function. Okay. All right, let me give you the next one. Turn your page up. Page number. No. No, let's get through these notes today and then tomorrow. We'll just do practicing the rest of the week. Because like I said, once you know what a function is, it's pretty easy to pick it out. But you have to know how to pick it out from all the diagrams. Okay, go ahead and get this one put in. So now I'm gonna go boop-a-doo, dot, 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 functions. Hopefully you're kind of skimming these ordered pairs over. There are 4 relations again. Seeing if maybe you can determine which of the 4 is the function. Okay, let me highlight this. Now we're looking at a set of ordered pairs, okay, those list of points. So we have 1, 2, 3, 4. I'm going to give you about 30 seconds independently looking this over. All right, so maybe tell Bo what you think it is. So you can say, yep, Makai said that, or thought that. Okay. Go ahead and get that glue in, Christian.
Daddy knows. Already knows. I don't think that's which one's mine.
One? All right, Bo. What did you and Makai decide? Which one's the function? Number one?
Yes.
Y'all agree? Good. It looks like number one. Now, when you are given a list of ordered pairs, when you're given the points listed out, there's lots of commas, lots of numbers. This goes X, Y, X, Y, X, Y, X, Y. Write that down. What's the only values that I care to look at? The X's. So what's a good thing to do is to go through and just circle those X's. I find that's a nice way that the Y values don't kind of get in mixed up. Okay, so all I'm looking at are the circle numbers. Do any of those repeat? No, they don't repeat. So this is the function. No X value repeats. Okay, that one's the function. 2 is not, 3 is not, and 4 is not. I've X'd those out. Looking at number 2, if it's not a function, we would say no, because which X value repeats? Because 1 repeats. Okay. On number 3, which value repeats? No, because 4 repeats in those X values. So it's helpful if I just circle the X value, the first number in my points. Okay, do that first and then go look and see which of the number repeats. I got 2 -5s here. So no, -5 repeats. Okay. So if it ever says explain your reasoning, take your AirPods, take your headphones out. One's already. Okay. All you have to look at is the X value. So if it says justify your answer or explain your reasoning, you just say no, it's not a function, and then just say what value repeats. Okay, just say what X number or what X value repeats. Okay. Everyone usually whenever in algebra class and you say function, everyone's like, oh my god, what's a function? That's so scary. It's not scary. It's just don't get an X value that's the same. Okay. I start off with the table and the set of ordered pairs because those are the easiest to recognize. Okay, I think the table is actually the easiest because the X values are kind of already grouped together. Okay, when it's in the set of ordered pairs, you've really got to make sure that you're looking at the X values, but it's still fairly simple to look at. I've changed everyone on you, Miss Carlton. They wanted to sit closer, so I bumped them up. All right, so that's it for set of ordered pairs. Okay. So in the future, if you're looking at a set of ordered pairs saying, I wonder if this is a function, go back to this page, okay? Next page, now we're gonna look at mapping diagrams. Ooh. These are a little tricky because they're new.
This is bad. This blue is dying because we have the blue.
We're still recording. This is good stuff, guys. It better work out.
What? I know.
Stuff, dangerous stuff.
Oh, that's like
Is this the last one?
This one and then don't miss. You better. Alrighty, let me get mine glued in. Dot, 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 still doing functions. Huh? Alright, here we go. Now we're looking at these new things called a mapping diagram. You have 4 mapping diagrams here. So 1, 2, 3, 4. So you have 4 relations because a relation is just a group of points. Okay, a group of points together, that's a relation. It's probably just the only thing here about these mapping diagrams is they're a little bit harder to read. Okay? So, how we read the mapping diagrams, just a reminder, is the x values are on the left side. Here are the x's. And the y's are on the right side. Okay? So if I were to list these points out, just like I did with the warm-up mapping diagram and listed those a few of the points out, if I listed these out, this would be 220 because it goes from 2 to 20. I also have an arrow from 2 to what? 40. So I'm looking at 2, 40, and then I'm looking at 4, 40, and then I'm looking at 3, 30. I feel like we're talking about time here. Okay? 330. So that might be helpful on a mapping diagram to list the points out. And then you're looking at x and y. So you're kind of making like a table. Okay? Is number 1 a function?
No.
No, because which number repeats? 40 does repeat and 2 repeats. Which ones, the x's or the y's, cannot repeat?
Yes.
The x's cannot repeat. So it has 2 2's. What you need to look for is an arrow, more than one arrow coming off of those inputs here. So this 2 has 2 arrows. It can only have 1 arrow coming off of each x value. Okay? You can only have 1 arrow coming off of each x value to a y value. If there are multiple arrows coming off of that 1 x value, since we don't list them out, we only listed out that number out one. Remember we said the numbers don't repeat on the mapping diagram, so you're not going to physically see that number listed out twice. So you need to look for more than 1 arrow coming off of that x value. Okay? Is number 2. Okay, so I'm going to put a line here. No, this is not a function because the 2 repeats. Okay. Is number 2, is this relation a function? No? Which x value repeats? The 1 here. We have 1, -0. I don't even know that was a number. And then 1 to 15. So there's 2 points that have 1 as the x value. So this one's a no because the 1 repeats. All right. What about number 3?
Yes.
Is that a function?
Yes.
Yes, because none of these numbers repeat. They each have their own arrows. So this is the function. That one's the winner there. That's the function. No x value repeats. Okay. So that's why the mapping diagrams are a little bit more tricky than the table and listing the points out, is because you have to make sure you are looking at the arrows. Okay, look at the arrows. So number 4 obviously is not a function because which x value repeats? The 1 repeats. It has 1 going to a 5 and 1 going to a 4. Because if you look back in your mapping diagram from your yellow foldable 8.1 mapping diagrams, it says the numbers do not repeat. So you're not going to see the numbers actually listed out more than once. So you have to really pay attention to the arrows. Okay? And you'll notice, well, does the So when did a function have? Yes, okay. So number 3, this is the function. None of the x values repeat, but do you notice how 5 has 2 arrows coming to it? That's okay. The 5 can be listed out twice. That means there's a 1, a 5, and a 5. That's okay, just the x values. Okay, just looking at the left side. Okay, let me give you out the last one. What diagram is this going to be?
More blue.
A graph. This is the last one here.
More blue.
Huh? All right, last one. Alrighty. Dot, dot, dot. I bet you do. Alright, everyone should now be looking at graphs. Graphs, graphs, graphs. This is the last diagram. This is the last form we're going to look at here. Graphs. Okay. And graphs, you can think about graphs a little differently, determining whether they're a function or not. Yes?
You can think of them like a straight line.
Yeah. There's this thing called a vertical line test. Okay, so down here at the bottom, does the graph pass or fail the vertical line test? That is a new vocabulary word. Vertical line test. Write that down. If I write down, you write down. And I'm going to tell you a little definition here of what a vertical line test is. Whew. Okay. If a relation passes the vertical line test, what that means is that there's only 1 point on each, we're going to say imaginary vertical line. Because we're going to draw, you're not going to see it, we're going to draw a bunch of vertical lines. That you draw. Is it? Okay, yeah, I can. Yep, I can. Okay. Does the graph pass or fail the vertical line test? And the vertical line test states that if you draw a bunch of imaginary vertical lines on the graph, okay, boom, 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 straight up and down, you can only have 1 point from that function, well, 1 point from the graph on the imaginary vertical line to be considered a function. Okay? So if I go through here, I'm going to use a different color because I don't think that's going to show it very good. Okay, let's try using light green. I'll use the lighter green. Okay, so if I go through here, so there's obviously just a bunch of points plotted here. It may just be points and it may actually be a connected continuous graph, okay? So if I go 1, I'm just drawing some imaginary vertical lines here. If I draw this line, this imaginary vertical line, 1 point on it. This one here, there's 1 point. This one's got 1 point, 1 point, 1 point. Okay, so right now that's looking like our function, okay? So down here, let me show you what I mean, okay? If I draw, let's just assume that these points are lined up. Here's one here, here's one there. Do you notice there's 2 points on the vertical line? Yes. Okay, so this one right here and this one right here, not a function. I'm gonna number these. 1, 2, 3, and 4. 1 is the function. Okay? And you can say that because it passes the vertical line test. And no, you may not abbreviate VLT. Okay? It's too soon to abbreviate VLT. Maybe next week I'll let you abbreviate. But right now I need the words spelled out so that you know what VLT is. Because so many times in the past I've had people say, oh, it's the pencil test. Where you take your pencil across. I'm like, it's called the vertical line test. Yes?
Why can't it be 4?
Why can't it be what?
4.
4 what?
4. The number 4.
Oh. Give me a second. I'm getting to it. Give me a second. Okay. So this one's a function. Only 1 point each vertical line. Number 3, not a function. Okay, because there's more than 1 on the vertical line. Okay. Even if it was just this. Even if it was just the 1 vertical line. Okay. If I'm looking at number 2, if I drew a point out here to the end, yes, there's only 1 there, but anything anywhere else, there's 2. There's more than 1, so that one's no, not a function. Okay? And this one was no, not a function. No, because it fails the vertical line test. It's very easy when it's a graph to say, yes, it passes the vertical line test, it's a function, or no, it fails the vertical line test, not a function. Okay? So number 4 is what they were asking about. Number 4 is the only line that completely fails the vertical line test. If I drew 1 vertical line, all of its points are on that same vertical line. So that's no. That one completely fails the vertical line test because all of the points are on that single vertical line. Good. I know, right? It's hard to think, and they're like, oh, okay, yeah, that makes sense now. A horizontal line would be good, but a vertical line, nope. Okay, this wording of passing, does it pass or fail the vertical line test? That only works for graphs, okay? Vertical line test only works for graphs. Do not tell me, if I give you a table, don't tell me, yes, it passes the vertical line test. I only want you to say it passes the vertical line test or it fails the vertical line test if you are using vertical lines on a graph, okay? I also don't want you to like sketch your own little graph out to the side that's like super not accurate and be like, oh, it passes. No, okay? If you are given a graph, you can use the vertical line test. Give me a thumbs up. Vertical line test only when it's a graph, okay? When it's a table, set of ordered pairs, or a mapping diagram, you look and see if the x value repeats, okay? Or if each input has its own output, if we want to be fancy. That is the last page of the notes. For 8.2 functions, we are going to practice this tomorrow and Friday. Okay? So I'm going to hit